Hello students, good morning. A warm welcome to all in our online session. I am Sushila Ghuge from Dr. Babasaheb Ambedkar School. So students, today also we are going to learn very interesting concepts from science. Are you ready? Show me thumbs up. All are ready? Okay. So students, tell me. Yes, beta. Yes. All are ready. Okay. So we will tell me in last session of science what we have studied last time. We have started new lesson. We will tell me name of that lesson.
Effects of light.
We have started one new lesson. Do you remember?
Sound, production of sound.
Yes, very good. Sound
Sound, production of sound.
Yes, beta, good. Sound and production of sound. It is 18th lesson from your science textbook. Okay. So in that, we have learned some new concepts. Do you remember that concepts? Anyone remember?
Yes.
Yes, beta, tell me.
Hello, miss.
Yes, beta. Yes, you can speak.
We can learn about oscillator, oscillation, and oscillatory motion.
Very good. First,
and turning instruments.
okay. So we studied about sound. What is sound? How sound is produced? And oscillation, oscillatory motion, and oscillator. Okay. If we don't remember, then don't worry. We will do quick revision of these points. Okay. So everyone be ready. So welcome you all. What is name of our lesson? That is sound, production of sound. In this, we studied that sound is a form of energy and it travels in the form of waves. You can see on your screen. The sound travels in the form of waves. Okay. After that, we also learn periodic motion. Periodic motion means the motion is repeated again and again at fixed interval of time. And such type of motion is called periodic motion. For example, string of a musical instrument. If we plug the string of tanpura, it vibrates and comes back to its central position again. This type of motion is called periodic motion. And we also studied that sound is generated by the rhythmic vibration of an object. Vibration is needed for generation of sound. Okay. Next point, we studied that oscillator. You can see here a swing or a pendulum that moves back and forth is called oscillator. Next, we studied that oscillation. Oscillation means when an oscillator moves from one end to the other and returns to its starting point, then it is said to have completed one oscillation. See, this is one oscillator. And if the oscillator moves from this point, A to P to B, and again returns to its starting point, then we can say this oscillator completed one oscillation. Okay, this is oscillation. Next point, we studied that oscillatory motion. What is oscillatory motion? The back and forth motion of an oscillator on either side of a central position is called oscillatory motion. See, this is swing. This is mean position of swing. And this swing moves back and forth, back and forth. This is called oscillatory motion. Okay. So today also we are going to learn some new interesting concepts. So in this module, you will learn about time period of oscillation and frequency, interrelationship between time period of oscillation, length of the pendulum, and frequency. So there is one more new concept, that is amplitude of oscillation. See, what is amplitude? You can see here a pendulum, and the maximum distance covered by an object on any one side of its central position is called amplitude of oscillation. Here you can see in this figure, this PA, this is amplitude. This pendulum's maximum distance is this. So PB is amplitude, or PA is also amplitude here. Do you understand amplitude? Amplitude means the maximum distance covered by an object. This is maximum distance covered by this pendulum to one side, to its one side. So PB or PA is the amplitude here. Now see, you can see in these waves, amplitude means the maximum distance. This is maximum distance and it is amplitude. In this wave, we can say this is amplitude. This is amplitude. This is amplitude. Okay. Now, if there is higher the amplitude, sound is louder. If amplitude of any object is higher, its sound is louder. And if amplitude is lower, then sound is softer. You can see difference here. Higher the amplitude, louder the sound. And lower the amplitude, softer the sound. So, if we apply small force, then amplitude will be small and soft voice produced. And if we apply large force, that time large amplitude is there and we can hear loud sound. Okay? Do you understood what is amplitude? Everyone? Amplitude means maximum distance covered by an object in one. Okay? Now next one. Yes. Next concept is time period of oscillation. Now we know that what is oscillation? The back and forth motion of an object or back and forth motion of an pendulum. It is called oscillator. And the time required by an oscillator to complete one oscillation is called time period of oscillation. See here. See, this pendulum moves from A to P to B and again returns to A. This is called, what this is called? This pendulum completed one oscillation. Okay. If this pendulum moves from point A to point B to point B, and again it returns back to its original point. Then it is, we call this pendulum completed one oscillation. And the time required, how much time this pendulum take to complete this one oscillation, it is called time period of oscillator. Okay. In 1 second, how many oscillations are completed? It is called time period of oscillation. And the unit of oscillation is second. Unit of oscillation is second. Okay. Now next one. Next important point is frequency of oscillation. What is frequency? See, the number of oscillations completed by an oscillator in 1 second is called the frequency of oscillation. How much oscillations complete by an oscillator in 1 second? It is called frequency of oscillation. Do you understood this? In 1 second, the oscillator completes how many oscillations? It is called frequency. We will
Yes,
see.
understood.
Yes, very good. So here is formula to calculate the frequency. And the formula of frequency is denoted by small n. See here. And the formula for calculation of frequency is 1 upon time period of oscillator. What is formula for calculation of frequency? 1 upon time period of oscillation, means T. Time period of oscillation is denoted by T. Okay. And the unit of frequency is hertz. HERTZ. We can write it HZ also. And 1 hertz means there is 1 oscillation in 1 second. If the frequency is 1 hertz, it means the oscillator complete 1 oscillation in 1 second. Okay. So you can see here, this is waves, longitudinal wave and transverse waves. We know that sound is propagated through medium and it travels like in the form of waves like this. Okay. And here you can see in this 1 second, this object completed 1, 2, 3 oscillations. So here what is frequency? 3 hertz. Okay. What is frequency here? 3 hertz. Because frequency is the number of oscillations occurring in 1 second. And here in 1 second, here 3 oscillations completed. So frequency of this object is 3 hertz. Now see, if wavelength is longer, the frequency is lower. Remember this point. If wavelengths longer, the frequency will be lower and the pitch of sound is also lower. We will see this afterwards. Pitch of sound. What is pitch of sound? But remember this. If longer the wavelength, lower the frequency. And if shorter the wavelength, higher the frequency. This is in inverse proportion. Longer the wavelength, lower the frequency. And shorter the wavelength, higher the frequency. Means here in 1 second, 1, 2, 3 oscillations completed here. And here in 1 second, 1, 2, 3, 4, 5, 6, 7 oscillations completed. So if wavelength is shorter, frequency is higher. And if wavelength is longer, frequency is lower. Okay. Now we are going to learn relationship between the frequency and the length of the pendulum. And for this, we are going to do an activity. Wait a minute. Okay. I'm going to show you one object. Can you see this? Can you see this setting? Yes.
Yes, miss.
Okay. This is thread and I tie one ball here. So this is works as a simple pendulum. Okay. Here is, you can see simple pendulum.
Yes.
And if we take this pendulum here and swing, see what happens. These are called oscillations. Okay. And for this,
Yes.
to know the relationship between frequency and length of pendulum, we are going to do this activity. For this, we are using this table and stopwatch. We need one stopwatch also. I'm going to use this device for stopwatch. Okay. This stopwatch I am going to use. So we will start our activity. Wait a minute. Okay. Now can you see this setting?
Yes.
Perfectly.
Not perfectly, because in online we cannot do, you cannot see perfect setting, but you will understand.
Okay.
Okay. This is one stand.
Yes.
This is stand. I use this stand to support this pendulum. Okay. You can see I tie this pendulum to this stand here. Okay. And now our pendulum is ready. Now what we have to do? First we have to do measure the length of this pendulum and we will calculate how much time required for 10 oscillations. Now you know that what is oscillation?
Yes.
Yes.
See, I will show you one time. If I swing this pendulum from here, it go and come again to here. It is called one oscillation.
Okay.
See once. This is one oscillation. See. It come again here. This is called one oscillation. And we are going to measure the
Yes.
time required for 10 oscillations. Then we
Okay.
difference or what is relation between them. For this, first I'm going to measure length of this pendulum. And it is 24. With the scale, I measured this length. It is 24 centimeter. I write there in this chart. It is 24 centimeter. Okay. Now I'm going to start oscillations and stopwatch also. Okay. Observe.
Yes.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this oscillator completes 10 oscillations in 9.68 seconds. Here is stopwatch. I think you cannot see, but here is 9.68 seconds. Okay. Now, what I'm going to do, I'm decreasing length of this thread. Okay, see,
Yes.
I have decreased length of this thread. Now, I'm measuring length again. It is 18 centimeter. Okay,
Yes.
18 centimeter. Again, we will start with our activity. See, again, I'm going to swing this pendulum.
10 times.
1, 2, 3, 4,
4.
5, 6, 7, 8, 9, 10. Actually, it vibrates. Okay. The time is 8.81 seconds. 8.81 seconds. I noted that. Again, I'm going to decrease length of this pendulum. Again, see. Now it is shorter. Yes. Now it is shorter. Okay. Again, I measure the length of oscillator, means this pendulum. It is 12 centimeter. Now again we'll do this. See. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, finished. So time is 7.77 seconds. Okay.
मीन्स सेकंड टाइम कितने आया था?
8.81. You can see here. Okay.
Yes.
First time length of oscillator is 24 centimeter and time required for 10 oscillations is 9.68 seconds. Second time length of oscillator is 18 centimeter and time required for 10 oscillation is 8.81 seconds. Third time 12 centimeter and time required is 7.77 seconds. Now we will do this calculation. Back to my screen sharing again. Wait. Okay. Can you see this chart?
Yes,
Yes.
Yes. Okay. Now we took 3 observations. I'm writing that observations in this table. See, first time, what is the length of oscillator?
24 centimeter.
Yes, 24
centimeter.
centimeter. Okay. And that time, how much time required?
9.68 seconds.
16 seconds.
68.
68 seconds. Second time, what is the length of
18
oscillator?
centimeter.
18 centimeter.
18 centimeter. And what is time required for 10 oscillations?
18.81 seconds.
8.81 seconds. Third time, what is
12
length of
centimeter. 12 centimeter.
centimeter? And what is time required for 10 oscillation?
7.77 seconds.
7.71 seconds.
77.
Sorry, 77 seconds. Sorry, it erased all. I'm writing again. Wait a minute. Will you do this calculation? What is time period of oscillation? This is 24 centimeter, 9.68 seconds. 18 centimeter, 8.81
81 seconds. 12 centimeter.
centimeter, Required
7.77
77
seconds.
seconds. Now do this calculation. What is next? Time period of oscillation. So what is formula for time period of oscillation? T equal to T upon 10 seconds. Why we took here 10? Because 10 oscillations completed.
Okay.
So do that calculation. Means 9.68 divided by 10 comes 0.9. This is 968 and this time is in second. Next one is 8.81 divided by 10. It will be 0.881 second. Next one is 7.77 divided by 10. Answer is 0.777 seconds. Okay. Now we have to calculate frequency also. See frequency. And what is formula for frequency? 1 upon
T.
Yes, 1 upon T. T means what? Time period of oscillation. Okay.
Yes.
So first one is 1 divided by 0.968. What is answer? It is 0.103 and it is in hertz. What is a unit of frequency? What is the unit of frequency? Hertz. Here is written.
How
Hertz.
do you find this?
I'm using calculator, beta. Okay.
Yes.
Here is formula, na? Formula is given 1 upon T. What is formula for calculation of frequency? 1 upon T. So
Yes.
here is 1 and what is T? T means this time period of oscillation. So first time I took 1 divided by 0.968. Now second time I'm taking.
I was asking that how you solve this.
Okay. I'm using calculator. And second time 1 divided by what will come?
8.81 seconds.
1 divided by 0.881. So answer is 1.135. Okay. Now next one is 1 divided by 0.777. It is wait a minute. Second one I'm doing again.
Okay.
It is second one is wait. It is 1.126.
126.
Yes.
Okay.
And here next one 1 divided by 0.777. It is 1.28 and 7. Okay.
Okay.
So now our observations are ready.
Yes.
From these observations, what you understood? Now your chart is ready. Okay, with calculation. From these observations, what you understood? Can you tell me? See, here, if length of oscillator is decreased, see, first time 24 centimeter, second time 18 centimeter, third time 12 centimeter, means length of oscillator decreased here. And
Yes.
here you can observe time period of oscillation also decreased. See, here is 0.968, 0.881, 0.777. Means here is decrease now. Decrease in time period. Yes?
Yes.
Yes or no?
Yes.
Miss.
Yes. So here we decrease the length of oscillator. So time period also decrease. Okay. But observe this column, frequency. Frequency will increase.
Yes.
Here is first frequency is 0.103. Second one is 1.126. Third one is 1.287. Means your frequency increase.
Yes.
From this, we can infer that if length of oscillator decrease, the time period of oscillation also decrease, but the frequency increases.
Yes.
Okay. And we can also say that if length of oscillator increase, if length of oscillator increase, the time period also increase. Okay. We can
Yes.
say like this. So from this, we know that the pendulum with a longer string has a lower frequency. Okay. It means it swings back and forth less. Now, there is one more experiment for this, to show that what is relationship between amplitude and time period. Okay. There is one more experiment like this only, same. But that time, what you have to do? You have to keep amplitude same. Sorry, length of the pendulum you have to keep same. This length. This is length of pendulum or oscillator. You have to keep here same. For example, you can take here 30 centimeter, and for all observations, length of oscillator or pendulum will be same.
Okay.
But
Yes.
you have to change amplitude. What you have to change? Amplitude of object. Means, what is amplitude?
The
Amplitude
maximum
means,
distance covered by an object is called amplitude.
yes, very good. Amplitude means maximum distance covered by an object. So amplitude, you have to say, swing pendulum first time small, then little larger, then larger. Means you have to increase amplitude and you have to record observations. Okay, this activity you can do at home. Okay, and from
Yes.
that, from all these two activities, what we found that the time period of oscillation depends on the length of pendulum. Okay, if length of pendulum increase, time period also increases. And when you do this second activity, that time there is no change in frequency. The frequency remains the same even if the amplitude decreases or increases. Okay? There is no effect of amplitude on frequency. Okay? Remember these two sentences. If the time period
Yes, miss.
increases, time period increases if the length of the pendulum increased. And we can say opposite sentence also. Time period decreases if the length of the pendulum decreases. Okay. And second, the frequency remains the same even if the amplitude decrease or increase. Amplitude, the maximum distance covered by pendulum, increase or decrease. It not affect the frequency. Okay. So this is all for today. We will see summary what we have studied today. We will see that. First we saw that the time required by an oscillator to complete one oscillation is called the time period of the oscillation. What is time period? To complete one oscillation, how much time is required? Okay. Second one, frequency is the number of oscillations occurring in 1 second. In 1 second, how much oscillations occur? It is called frequency. It can be 100 hertz, it can be 50 hertz. If in 1 second, 50 oscillations occur, then what is frequency of that object? It is 50 hertz. Okay. And the unit of frequency is hertz. This is unit of frequency. Next one, the time period of oscillation depends on the length of the pendulum. By experiment, we proved this. The time period of oscillation depends on the length of pendulum. The time period of oscillation increases if the length of the pendulum is increased. We saw this in experiment. The time period of oscillation increases if the length of the pendulum increased. And the frequency remains the same even if the amplitude decreases or increases. First time we saw that frequency increasing. If the length of the oscillator decreases, the frequency increases. But if you do second experiment, in that you can see that if the amplitude changes, there is change in amplitude, then also the frequency remains the same. Okay. So we will do speech. So we come to know that if you understood these points or not. Okay. So first question is, okay, the first question is, the frequency of sound is measured in. Options are A second, B
Option
hertz.
number B.
Second.
Yes.
Hertz.
Okay. Okay. So what is correct
B.
option?
B.
Option B is correct answer. Hertz.
Yes.
Everyone understood this?
Yes, miss.
Yes,
Yes,
we
miss.
saw that. Okay. So second question. The time period of oscillation increases if the length of the pendulum decreases, increases or all? Yes.
Increases.
Very good.
A.
Time period is directly proportional to length of the pendulum. So
Yes.
if the time
Option
period
number
of
C.
oscillation increases, the length of pendulum increases. Okay.
Yes.
Third question.
Option number C.
Yes, beta. Yes. Third question. Frequency is the number of oscillations occurring in dash dash second.
1 second. 1 second.
1 second.
Yes.
Option number
1
A.
second.
Yes, very good. 1. Frequency is the number of oscillations occurring in 1 second.
A. Option number A. Correct.
Oscillations hote hai. It is called frequency. Okay. Very
Yes.
good.
Yes,
Excellent.
miss.
Next. 100 oscillations in 1 second means dash dash. Now tell
D. 100.
yes,
100.
very good, very good.
Option number B, 100 second.
D, it is
D.
D.
yes, 100
number D.
oscillations in 1 second
100.
means 100 hertz.
Hertz.
Okay,
Yes, miss.
Yes,
very
miss.
good. Next one, dash dash remains the same even if the amplitude decreases or increases.
Frequency.
Frequency. A.
Very good. Yes, good
Frequency.
answer. Very good.
Yes,
Hello,
miss.
miss.
E remains the same even if the amplitude decreases or increases.
Yes.
Okay.
Yes,
Now
miss.
next question. These questions are for homework also. You can take screenshot. And I am asking here also. Next question
Hello,
is,
miss.
yes, beta.
Miss, you can read option, please.
Yes, yes. I'm reading, but that students giving answer, na? Okay, next time I will read all options. Okay. Now listen, second question. Question 7. What is the time period of oscillation?
Time required by an oscillator to complete one oscillation is called time period of oscillator.
Very good. Listen again. The time required by an oscillator to complete one oscillation is called the time period
Time
of.
period of oscillation.
Okay.
Yes, miss.
Okay. Understood now, everyone?
Yes, miss.
How much time required to complete one oscillation? It is called time period of oscillation.
Oscillation.
Now next question. What is the formula for calculation of frequency?
1 upon T.
1 upon T.
Time period
Yes.
of the oscillation is
Frequency.
the formula
Calculation
for
of
calculation of
frequency.
frequency.
N equal to 1 upon
1
T.
T.
N means frequency. And what is T?
Time
The
period.
time period of oscillation.
Time period of
Os-
Oscillation.
It is oscillation.
oscillation.
Okay?
Yes, miss.
Yes, miss.
Is time period of oscillation. So, formula for calculation of frequency is 1 upon T.
T.
Okay?
Yes,
So,
miss.
understood all these
Yes.
things.
Yes, miss.
And on these concepts, tomorrow we'll see next points on the frequency, amplitude, on these concepts. Next points are depend. And all these points we will see on tomorrow.
हेलो मिस
Yes.
Yes, beta?
मिस वो जो आपने होमवर्क के लिए वो टेबल दिया है ना
Yes. It is in your textbook only. On page number 120.
मिस मैं जब 30 सेंटीमीटर लेंथ है तो उसके सेकंड सेम आ सकते हैं क्या?
Length of pendulum, na? All for all observations 13 centimeter.
Yes.
Yes, you do that. But you have to change the amplitude, huh?
How?
to change amplitude.
Yes. चेंज करना है मतलब क्या? फर्स्ट टाइम आपको थोड़ा सा स्विंग करना है, नेक्स्ट टाइम थोड़ा ज्यादा स्विंग करना है. ओके? उसके बाद थोड़ा और ज्यादा स्विंग करना है. And you have to record that observation. Okay?
Yes, miss.
And also write down answer of these questions. Take
Yes.
screenshot of this.
I take the screenshot.
Okay, very good. And all are very good in study, paying attention, very good. Okay, so remaining points we will see on tomorrow. Okay? Okay?
Yes.
Okay.
Yes, miss.